Hi, I'm Rez. I am a professional game programmer. I do electrical engineering as a hobby. Let's talk a little bit about what this circuit actually is doing. Now, a lecture on op amps is perhaps beyond the scope of this of these videos, but I thought instead we would just do a basic look at what we've got. So the circuit that we have, which is based on this one right here, come on, focus. The circuit that we have that's based on this one right here, they don't really draw the schematic, which I kind of wish they did. They did that in some of the other ones, but they're not doing it here. Essentially what we have is we have the op amp here in the middle. We have an inverting and a non-inverting input. And a lot of times they're drawn opposite of what I'm drawing here, but I'm just doing it this way because I think it's easier for us to look at it. Let me kind of get the shadow of the camera. I don't think I'm going to do much better. Okay, so here we've got this, and we've got this guy coming out. Now, this part of the circuit right here doesn't change. So this is going to come out to our speaker like that. This is going to come to our 0 volt reference. That's ground right there. So nothing really changes here. Now this inverting reference is set to ground, just like that. So here's our current schematic. Now here's the part that's changed. Coming right out of the output of this amplifier, we have coming up, we have a resistor. This is our 15K. And we have a capacitor. This is our 0.1 microfarad or 100 nanofarad, however you want to write that. This comes to our inverted or non-inverting input. So this is the thing that's different. And now none of this really changes. If you saw my other technical video, I mean, this is plus 4.5 volts. And then this guy is connected to, ground. This is 0 volts here. So this is what we've got. Now, the way that this is going to work is if we just remove this part of the circuit here, and we just have this output happening, what we're going to see is it's inverting. So it's going to essentially invert this into, it's going to try and slam that up to the top. It's going to put that as high as it possibly can, in our case, 4.5 volts. So this will be 4.5 volts right here on the output. So without any other circuitry happening, we're going to get 4.5 volts. Now, and we don't have an input coming from here, right? So this is going to be driven by this. So this'll slam up to 4.5 volts, its maximum. That 4.5 volts, while it's going to drive this, it's also in parallel going to drive this. So we have this RC circuit here. RC stands for resistor capacitor. This RC circuit here, what's going to happen is this capacitor, just like we've seen before, is going to charge up like that. We're going to see it charge up. As this capacitor charges up, you can think of this almost as a resistance. Like when this first starts, this capacitor is going to charge up, and then we're going to start seeing a higher kind of voltage here at this point. So as that's going up, this value is going to start dropping. And eventually, this will basically get high enough to reverse the output. So the output's going to be something like this. As that capacitor is discharging, the capacitor, it's going to be kind of like this. I guess it's going to be more kind of like this. It's going to reach some threshold. It'll drop down like that. It'll discharge. It'll kind of do this. I think that's right, but we'll look at it at the oscilloscope. I think that'll be fun. It's been a while since I've had to dig into some of these circuits. But that's essentially what's happening here. We're creating this little oscillator. So let's take a look what that looks like on the oscilloscope. Okay, so I have hooked this up to the oscilloscope. I actually have both traces running right now. Our 0 volt reference is here in the center. I have both a yellow and a purple trace happening. The yellow trace is on the output, like right after that filter capacitor. The purple trace is on the input right at this position here on the inverting input. Sorry, non-inverting input, on the plus sign on the non-inverting input, or basically here on this pin 3, just so we can kind of see what's going on. So let's turn this on. And the shape of the yellow trace is not exactly what I would have expected, although we'll see that in a minute. The purple trace is more or less what I would expect. It is showing a capacitor discharge, really, right? That's a capacitor discharge curve that's happening right there. So we're watching that happen, and then it slams to the other side, and then it charges back up, and vice versa, and so on. The yellow is not exactly what I would have expected. It's a series of sort of positive, negative pulses. Now, interestingly, if I unplug the speaker, that is what I would expect. This is much closer to what the output I would expect. Let me kind of tilt this a little bit. And I'll pause this so that you can see it. This yellow trace, I'll turn off the purple one. This yellow trace is pretty much exactly what I would expect here. So what we're seeing here is it's this thing that I was showing. It sort of slams up and down as that capacitor reaches its points, with a little bit here as it's trying to kind of figure itself out. But that's what I would expect on the output of this. Now, right now I have the output just open on this sort of other capacitor here. If I move it over here, let's see what happens. I'm going to turn this off in case I short this. There we go. Let's turn this back on. Let's run this again. Yeah, see, it's about the same. Now I'm not getting the filter because it's not going through the capacitor. But it's the same basic idea. You can... Uh-oh, you're not happy with that, are you? There we go. It's still the same basic idea. This time it's just, we're not filtering out that DC. So we're going from 0 to like 4.5 volts is, I'm pretty sure, what that peak is right there. So yeah, that's what we have now. And then if I were to take this and put this on the other side right here. Oops, sorry about that. Put this on the other side like this, and then run it again. Now we just have that filter. So that's what's going on. If I plug in the speaker, then we start getting that other waveform as the speaker is basically consuming this input. Let me let this run. Oh, this button is not pressing. There we go. So we're here, and as soon as I tie the speaker to ground, now we're getting this on the output as the speaker sort of consumes this load. And if I'm honest, I'm not 100% sure why this waveform is changing. This is something I have to look up. I'm not sure why the waveform is so significantly changing like this. My suspicion is that it's pulling... I'm actually not sure why. But here we are. So that's basically it. That's what's going on here with this output. That's this feedback loop. And again, very, very common type of circuit to have this sort of feedback going like this. It creates, it's used for various types of amplifiers and all that kind of stuff. So that's the idea. Now we'll be able to play with this. We'll be able to get different we'll be able to get different like values in the circuit, which is right here. We'll be able to get different things going on that will allow us to play with this. So I'm curious where we go from here. We're getting into kind of, circuit bending territory here. So that's all I got. Thanks so much for watching.